Hi and Assalamualaikum warahmatullahi wabarakatuh. Okay, so we are going to discuss about the magnetic sensor. Alright, magnetic sensor, or we call it as a Hall effect sensor, used to determine position, angle, or displacement. Alright, there are two types of Hall sensor or magnetic sensor, which is linear and threshold. Okay, so a linear sensor usually incorporate an amplifier for the easier interface with the peripheral circuits. Okay, so if you can look at this figure, the first figure is this one is a linear type sensor, and this one is the threshold type sensor. Okay, Hall effect based magnetic Hall effect based magnetic position sensor is a sensor which is transducer that varies its output voltage in response to the magnetic field. Okay, so this Hall effect sensor can be used for us to sensing proximity switching, position, speed detection, and current. Okay, so a linear sensor usually incorporates an amplifier for the easy interface with the peripheral circuit. Okay, for linear sensor, it can be operated over a broader voltage range and are more stable in a noisy environment. Okay, compared to the threshold type sensor, okay, they need a Schmitt trigger detector with a built-in hysteresis. Okay, so what's the difference between the linear and threshold types? Okay, so first of all, you can look at this circuit. Okay, so for linear, there are only have amplifier. Alright, so for the threshold, they have amplifier, but they have additional things inside the circuit, which is we call it a Schmitt trigger. Okay, another things we can look at their output. Okay, so for linear, the output is mostly like this one, like this figure, which is the output voltage will be directly proportional to the input. Okay, so but for threshold, there is two state, which is they have mode state, usually in on condition. Okay, and another one, they have off state, which is in condition off. Okay. In threshold sensor, they have two level of output, which is either it's on or off. Okay, for threshold, when we apply a magnetic field, flux density exceeds a certain threshold, the trigger provides a clean transition from off to the on position, which is they will makes the sensor to be in the on position. Alright, so for the position and displacement measurement, the Hall effect sensor must be provided with a magnetic field source and interface electronic circuit. Okay, so for when we talk about the magnetic field, they has two important characteristics that we need to be noted, which is magnetic field. They depends on the flux density and also a polarity. right? Which is for better responsivity, magnetic field lines it must be normal to the flat surface of the sensor, and it must be correct polarity. For example, this is our flat surface. Oh no. Okay, so this is our okay, begin. So this is our flat surface. Okay, so this is our magnetic field lines. Okay, we need to make sure that it must be perpendicular between the magnetic field and the surface that we need to be measured. Alright, and then another one, it must be in the correct polarity. Alright. Okay, so the field strength of the magnet should be investigated before we perform or we design a sensor. Okay, so the strength will decrease greatest at the pole face, and it will decrease as we increase the distance from the magnet. Okay, so the magnetic field can be measured their value by using Gauss meter or calibrated Hall sensor. For the threshold type Hall sensor, the longest distance at which the sensor goes from on to off mode, we call it as a release point. Okay, which is it can be used to determine the critical distance where the sensor useful or functions. Okay, so the magnetic field strength is not linear with the distance, and it depends greatly on the magnet shape. Okay, the magnetic circuit and the path traveled by the magnet. So the Hall connective strip is situated at some depth within the sensor housing, which is it will determine the minimum operating distance. So a magnet that we use, it must be operate reliably with the total effective air gap in the working environment, and it must be fit in the available space and must be mountable, affordable, and available, so for us to choose the best magnet for our sensor. Okay, so if you can see at this figure, this is the example of Hall effect sensor in the interrupter switching mode. Okay, so in this mode, the activating magnet and the Hall sensor are mounted on a single rack assembly with a small air gap between them. Alright, so this one, they have concentrator. Okay, this one our sensor, and this one our magnet. So for if you can see at the figure A, okay, there is no vein or interrupter between the sensor and magnet. So this condition is in the on condition. Alright. Alright, so what happen if we put a ferromagnetic plate or vein placed between the magnet and the Hall sensor? Okay, the vein will form a magnetic shunt that distorts the magnetic flux away from the sensor, which will cause the sensor to flip to the off position. Alright, so if you can look at this figure, so this one, it interrupt the magnetic flux from the original magnetic flux, right? So it will cause the sensor to become in off condition. Okay, so that's how the Hall sensor working as the interrupter switching mode. Alright, so I hope all of you will be understand the working principle of this magnetic sensor, which is you need to know that the Hall sensor, it will depends greatly on the magnetic field of the magnet, and also the shape of the magnet, and the density field strength of the magnet. Alright, so see you on the next part of this lecture. Thank you.